Hello, this is Joel Garcia, and the purpose of this lab was to determine the mass of a black hole using VPython. In the beginning, we were given initial conditions of the mass of the star to be 1.989 times 10 to the 30, and a time step of 86,400 seconds, which is the amount of time in one day, as well as a black hole position of -2 times 10 to the 10 in the x direction, and 1 times 10 to the 10 in the y direction. In order to calculate the mass of the black hole, we must first find the net force of the system. So we use the original VPython program setup, and as you can see, the mass of the star is what I said, 1.989 times 10 to the 30, and delta T is equal to 60 times 60 times 24, which is the same as the amount of seconds in one day. In the while loop of the program, I use this to calculate the V final and V initial, and in turn use these values to find the initial momentum and final momentum. This is important because it allows me to find delta P and delta V, which are both important in determining the net force. By taking the delta P and dividing it by delta T, I get dP dt, which can be used to calculate the net force on the system. It should also be important to notice that the net force has a perpendicular and parallel component, and in the program I calculated those as well. In order to calculate the parallel component of momentum, I took the magnitude of the final momentum and multiplied it by the unit vector of momentum divided by delta T. And to calculate the perpendicular component of net force, I took the magnitude of P final and multiplied that by delta P hat over delta T. Also, in my program, I included 3 arrows. One arrow to show the net force, another arrow to show the dP over dt parallel, which is the parallel component of net force, as well as an arrow to indicate the perpendicular component of net force. Also, under black hole mass calculation, that's where I actually calculate the mass of the black hole using the information I was getting. The starting coordinates of -2 times 10 to the 10 and a y direction of 1 times 10 to the 10. Since I know that g is equal to 6.7 times 10 to the -11th, I can manipulate the formula to isolate the mass of the black hole. When I run the program, I get a circular path, and I get a black arrow which indicates net force, a red arrow indicating perpendicular force, and a blue arrow indicating parallel force. And at the end of the program, I put a print function to tell it to print the mass of the black hole, and they end up with approximately 3.16 times 10 to the 31st. And when I plug that value into WebAssign, it gives me the correct answer. So I assume that the program gave me the correct answer. So what does this mean? I can conclude that the net force and delta P over delta T give you the same values, but they are different in the fact that the net force is a calculated value based upon the momentum, while delta P over delta T gives you net force. Also, dP over dt parallel and dP over dt perpendicular coincide with F-net perpendicular and F-net parallel. The what-if question asks, imagine if the black hole mass we found was replaced by a different black hole, but still placed at the same location. In other words, is it possible for you to find a value for the mass of the new black hole that is different from the mass you found from the original one? I would say no, because considering that all the initial conditions would still be the same, including the position, And in the formula I used, mass was not a factor, meaning I would find the same mass for the black hole.